Okay, here we go. This is a test. I hope this works well, but I wanted to be able to try explaining week three's homework assignments, actually drawing out the examples and the probabilities. So we're going to start with number one, and again this is week three. And for number one, we have Professor Mashley, who teaches two classes of statistics. He teaches Stats 201. Stats 201 has 7 sophomores and 3 juniors. He also teaches Stats 301. Stats 301 has 2 sophomores and 8 juniors. So Professor Mashley is teaching probability, and in order to teach probability, he's going to show what happens when he selects 2 cards, one card from a stack of Stats 201 students, and the other stack from a group of Stats 301 students. He also says that when he selects 2 cards, he'll always replace the first card back in its stack before he selects the second card. This action makes these 2 events independent. Okay, so A. What is the probability of drawing a junior's name on the first draw? So we know that because he's drawing this first draw, he's going to be selecting from the Stats 201 group. And in that Stats 201 group, there are 3 juniors. This means that the probability of selecting a junior on the first draw is 3 out of 10, or 0.3. Number B. What's the probability of selecting a junior's name on the second draw, given that a sophomore's name was drawn first? So Professor Mashley has told us that if he draws a sophomore first, he'll replace that card, and the second draw will also be from his Stats 201 group. So then we know that the second draw is also from Stats 201. So again, he's going to make that selection, that second selection from Stats 201. Because he replaces the card, the second event has had no bearing from what happened in the first draw. So again, the probability is 3 out of 10, or 0.3. Number C. What's the probability of drawing a junior's name on the second draw, given that a junior's name was drawn first? Again, these are independent events, but because he drew a junior on the first draw, the second draw will come from the Stats 301 class. So in the Stats 301 class, there are 8 juniors out of the 10 students, so the probability is 0.8. Number D. What's the probability of drawing a sophomore on both draws? Again, remember, he's replacing the card between draws. But because he drew a sophomore in the first draw, he will also draw a sophomore. The second draw will be also from Stats 201. So the probability, what we're basically asking is, what is the probability of drawing a sophomore on group 1, draw 1, and the probability of a sophomore on the second draw? Remember, the key word here is and we talked about when we use and, we're going to multiply these 2 probabilities together. So the probability of drawing a sophomore in group 1 is 7 out of 10, or 0.7. And the probability of drawing a sophomore on the second draw, again, is from Stats 201, so we multiply that times 0.7, which gives us a probability of 0.49. E. What's the probability of drawing a junior on both draws? So because we're drawing juniors, the first draw is from the Stats 201, which has 3 out of 10, or 0.3. But because it was a junior, the second draw will be from Stats 301, in which there are 8 juniors. So that gives us a probability of 0.24. All right, E. And let me just write these back out here again. We have Stats 201, 7 sophomores and 3 juniors. Stats 301 with 2 sophomores and 8 juniors. Question E asks, or I'm sorry, we're on question F. What's the probability of drawing one sophomore's name and one junior name on 2 draws, regardless of order drawn? So basically we're asking, what's the probability of drawing a sophomore on draw 1 and a junior on draw 2, or the probability of a junior on draw 1 and a sophomore on draw 2. And our key word is or, which means eventually we're going to add these 2 probabilities together. So the probability of a sophomore on draw 1 and a junior on draw 2 is sophomore on group 1 would be 7 out of 10, or 0.7, times a junior on draw 2. We're still in Stats 201 because the first draw was a sophomore, so that'll be 0.3 equals 0.21. The probability of a junior on group 1 and a sophomore on draw 2 equals 0.3 for 3 juniors in Stats 201. The sophomore is going to be selected from Stats 301 since the junior was selected first, and that is 0.2, which gives us a probability of 0.06. So now we take 0.21 and we add 0.06, and that gives us 0.27. So that's problem number 1. Problem number 2. An urn contains 7 blue chips, and 3 yellow chips. If the drawing of chips is done with replacement, determine the probability of A drawing 3 yellow chips. Because it's with replacement, again, these are independent events, so we would have 0.3 times 0.3 times 0.3. And that would give us a probability of 0.027. So this is the same as the probability of drawing a yellow on the first draw and a yellow on the second draw and a yellow on the third draw, so we multiply these together. B. What's the probability of drawing a blue chip on the first draw and a yellow chip on the second draw? Again, this is with replacement, so the probability of drawing a blue chip on the first draw is 0.7. We've replaced it, so the probability of a yellow chip on the second draw is 3 out of 10, so 0.3, which gives us a probability of 0.21. C. Drawing a blue chip on the second draw, given that a yellow chip was drawn on the first draw. So these are independent, and it doesn't matter what happens on the first draw, except for the fact that we want a blue chip on the second draw, which means the probability of drawing a second chip on the second draw, or blue chip on the second draw, is 0.7. D, same thing, a yellow chip on the second draw, given a blue chip was drawn on the first draw. These are independent events, so it doesn't matter what happened on the first draw. The yellow chip on the second draw would be the same probability if it was the yellow chip on the first draw. So the probability is simply 0.3. Then finally, drawing a yellow chip on the second draw, given that a yellow chip was drawn on the first draw. 0.3, because it doesn't matter what happened on the first draw. What matters is what happened on the second draw. All right, question number 3. In a production run of 300 units, there are exactly 20 defective units and 280 good items. So there are a total of 300 items altogether. So question A. What is the probability that a randomly selected item is defective? So we have 20 out of the 300 items that are defective, which gives us a probability of 0.067. Question number B. If 2 items are sampled without replacement, what's the probability that both are good? So the key word here is without replacement. Sorry about my spelling. So this makes these dependent events. So what's the probability that 2 items selected randomly are both good? So we have 280 good items, so our first selection, 280 out of the 300 are good. Then for our second selection, since we haven't replaced the items, there are only 279 good items remaining out of the 299 total items in the pool. So this gives us a total probability of 0.871. C. If 2 items are randomly selected without replacement, what's the probability that the first is good, but the second is defective? Again, these are without replacement, so that makes these dependent events. The probability of the second event is dependent on the outcome of the first event. So the first item is good, so that means the probability, again, is 280 out of 300. And then the probability that the second one is not good, we still have 20 defective items, but our pool is now 299, which means our total probability of selecting a good item on the first draw and a bad item on the second draw is 0.0062. I hope these make sense. Let me know if you have any questions.